Good morning. Today we're going to start the final meetings on 8 minutes student presentation. We have 10 students, 10 active students that will talk about their selected topic. And without further ado, so that we can have an effective presentation period, I would like to invite Bunga Edimia to prepare her presentation and start whenever she's ready. I would like to remind all of the attendees, the audience, that you need to evaluate all of the presenters. And after you're done with your assessment, you need to send or upload your assessment sheet to the following folder, and also to all of the presenters that already done their talk in the previous session and also in this session, to send their PPT or PDF of their presentation file into the given folder in the EduNext. Okay. Bunga?
Okay, can you see my screen, sir?
Yes.
Okay. Good morning, everyone. My name is Bunga Dinian Nandanasran Gultom, and I'm from Physics of Earth and Complex System Group, Faculty of Mathematics and Natural Sciences. So what I'm going to talk in today's presentation is about pore structure analysis of concrete using digital image of microcomputer tomography. And I've divided my presentation into three main parts. The first one, I will start with the introduction, and then the basic theory, and finally the method that we'll use in this research topic. And let me start with the introduction first. So as we know that the development of construction material is increasing rapidly along with the increasing of human needs in the field of construction industry. And one of the most popular construction material is concrete because it has several advantages. For example, high compressive strength. And the characteristic of concrete are greatly influenced by the pore structure. And this pore structure consists of shape, volume, size, and also its distribution. And another important to note that the porosity also plays a role in the relationship between the mechanical properties such as compressive strength. And so there are several methods that we can use to investigate the microstructure of our construction material. For example, mercury intrusion porosimetry or MIP, and then scanning electron microscopy or SEM. However, this method has a limitation. For example, MIP can only provide an information about open pore structure, and SEM only provide information on the 2D surface images. So in this research topic, I will use Microscopy because it has the ability to visualize the 3D structure of our pore structure in the concrete sample. And because it has been applied in various research topics, for example, in dentistry, rock physics, building materials, medicine, and many more. And so using the Microscopy device, the accurate microstructure of our sample can be obtained. So what is the purpose of this research? The first one, I will present the ability of Microscopy to reveal the microstructure of concrete, especially before and after compressive strength test. And then I will determine what is the correlation between the pore structure and compressive strength. And moving on to the basic theory that will support this research topic. So we need to know what is concrete itself. So concrete is a mixture of cement, usually Portland cement, and then water, aggregate, and admixture that form a solid mix. And as shown in figure 1, this is the illustration of concrete mixture. And usually it contains 1 until 2% of air voids, 25 until 40% of cement paste, and 60 until 75 of aggregates. And the this concrete constituent will certainly affect the resulting concrete. And so each of these concrete constituent has its own function. For example, concrete is used to bind the aggregate and fill the air voids between the aggregate grains. And one of the most popular cement is Portland cement. And according to STM C150, the Portland cement is divided into 4 types, that is type 1, 2, 3, and 4. And another concrete constituent is water. This is used as a hydrating agent, and we need to know that the higher the water cement ratio in a concrete, so the lower the compressive strength that we'll obtain. And another concrete constituent is aggregate. It is related to the good workability and produce a high strength. And based on its grain size, it is divided into 2 parts. That is fine, that has a grain size of 5 millimeter, and coarse aggregate, which grain size between 5 to 40 millimeter. And another constituent is admixture. It is used to increase the strength of our concrete. So how does the microscopy work? It is used based on the different attenuation of X-ray that produced from the X-ray tube. And this is X-ray will passing through the specimen on a rotating state. And so the detector will record a set of projection at any angle, and then it will be reconstructed to obtain the reconstructed image of our sample. And it is based on the Lambert-Beer, as shown in equation 1, in which the I is intensity of X-ray passing through the sample, I0 the incident X-ray intensity, mu the linear attenuation coefficient, and T is the material thickness. And to obtain the uniaxial compressive strength, the uniaxial compressive strength test will be carried out in this research topic, and it is defined as the maximum axial stress that a concrete sample can withstand before failure. And it's obtained by dividing the axial compression force by the surface area. And this is the illustration of uniaxial compressive strength of cylindrical concrete, as shown in figure 5. And next to the method that we'll use in this research topic. So the concrete samples were scanned using the Bruker micro-CT scan 1173, as shown in figure 6. And from this process, a set of projection image will be obtained. And after that, we will reconstruct this image. So we will get the reconstructed image, and I will use the several software to analyze the microstructure of our concrete sample. And this is the stage of digital image processing and analysis using software synthetic analyzer. First, we need to do the selection of volume of interest and then region of interest selection. And after that, we do the thresholding to convert our grayscale image from the reconstructed process to binary image, to convert into binary image, and then we do the bitwise operation. So we will analyze only the pore structure in our concrete sample. And after that, we use CT-Fox to do the visualization. And as shown in figure 7, this is the 3D visualization of concrete sample before compressive strength test. And after that, to visualize our pore structure and crack after compressive strength, I will use CT-Fox. And as shown in figure 8, this is the 3D visualization, the example of 3D visualization of our pore structure and crack after compressive strength test. Okay, I think this brings me to the end of my presentation. Thank you all for listening, and good morning.
Okay, good morning. Thank you, Bunga. So now we could move on to the second speaker. I would like to invite Darul Roni Rodiansyah. we have Daru Roni Rodiansyah in the classroom?
Yes, sir. Okay, wait. Gee. Could you see my share screen, sir?
Yes.
Okay. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum.
My name is Darul Roni Rudiansyah. I will present my research entitled Investigation of Synthesis and Electrochemical Properties of Copper Sulfide Nanoparticles for Supercapacitor using hot injection method. Okay. Sorry, sir. I have any problem. Oh. Okay. First, I will again review the background of doing research on supercapacitors. Okay. The need for fossil energy continues to increase, causing high dependence on fossil fuels, continuous pollution, global warming, and political tension between countries or regions. Alternative solutions offered renewable energy and increasing the efficiency of the transportation system. However, there is still a problem with this solution. Increasing vehicle efficiency requires kinetic energy to be stored each time the vehicle slows down or stops, thus requiring large amount of power. Meanwhile, the use of renewable energy has discontinuous nature, and power generation is still complicated. Therefore, a good energy storage system is needed for both problems. Okay, so one solution that can be chosen is use supercapacitor. Supercapacitor are electrochemical energy storage device that operate by electrolytic absorption mechanism with the advantage of having a high surface area, providing high power, and fast charging with a very long cycle life, more than 100,000 cycle. Also, two types of supercapacitors based on their energy storage system are EDLC and pseudocapacitors. The EDLC type supercapacitor work using a Faraday reaction that utilize the form double layer, whereas the capacitors use the redox reaction to store energy. Therefore, a good electrode is needed. Okay. The ideal electrode has the following criteria: high specific capacity, high grade capability, wide contact area, high porosity, have good cyclical, and have good cyclical stability. Materials that can be used as electrode are the transition metal sulfide. As in this picture, there are several materials, namely carbon nanotube, nickel sulfide, zinc sulfide, iron sulfide, and something like that. The advantage of transition metal sulfide is high electrical conductivity, like metals, high ionic diffusion, and narrow band gap. One of the interesting materials to study is copper sulfide. Copper sulfide, in from its structure and shape, copper sulfide has good high ionic diffusion, high chemical stability, low price, abundant availability, and has high theoretical capacitance. The method used also determines the performance of resulting supercapacitors. The method the method I use is the hot injection method because it has a short synthesis time and has controllable parameters to produce very small and uniform material. So, from the description that has been explained, this research was conducted with the following objective. First, investigating the synthesis and electrochemical properties of copper sulfide and fabrication of supercapacitor electrodes with high specific capacitance. Okay, next, in this slide, I will explain the research method. Two pictures that I made manually and photos that I took during the experiment. The setup, the tools I use is shown in this picture. The setup is shown in figure. There are many components such as nitrogen gas, thermocouple, lab jack, bubbler, screen condenser, mantle heater for heating and steering, and chiller for cooling. Okay, the experimental process was started by synthesizing copper precursor. Okay, the synthesis was carried out by dissolving copper chloride dihydride. Oh, sorry, my battery is low. Okay. The synthesis was carried out by dissolving copper chloride dihydride in 10 milliliter ethylene glycol. The powder was dissolved by stirring until a transparent green solution was obtained. Next is the synthesis of copper sulfide nanoparticles. The synthesis was started by dissolving 1 millimole urea and 0.1 gram capping agent in 40 milliliter ethylene glycol. Here I use capping is polyphenylpyrrolidone or PPP. After everything is dissolved, the solution is flowed with nitrogen gas to adjust the synthesis condition. This process is known as bubbling or degassing. Then the temperature is increased to 180 degrees Celsius. After the solution reaches that temperature, after the solution reaches the temperature, the copper precursor that has been made is injected to the solution so that reaction occurs. The reaction was allowed to stand for 30 minutes to form a dark solution like this. Okay, after being synthesized, there is a post-synthesis process and fabrication of supercapacitor electrodes. The post-synthesis process begins with cooling the solution to stop the reaction. Subsequently, the solution was washed and centrifuged.
Sorry to interrupt, but you have 1 minute to close your presentation.
Okay, sir. Centrifuged with 50 milliliter of acetone and ethanol. From this process, a precipitate shown in this figure is obtained. Furthermore, as the precipitate was dried, its temperature of 100 degrees Celsius 5 hours to obtain chips further as shown in this image. After that, fabricated electrode like a figure with conductive carbon black and binder. Next, deposit on nickel foam and stainless steel. After everything is finished, the electrode are ready and characterization is done to determine their performance. The characterization carried out were AES, CP, and BCD. for characterized electrochemical properties, XRD for crystallization characterization, and SEM and TEM determine the morphology of the materials and electrode made. Okay, so that's all from me. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you, Ronnie. Should move on to the third presenter. I would like to invite Sandy David Tambunan.
Yes, sir. Okay, good morning, Mr. Hari and everyone.
Good morning.
My name is Sandi David Tambunan from the Nuclear Physics and Biophysics Research Division, Faculty of Mathematics and Natural Sciences, Institut Teknologi Bandung. On this occasion, I will present my research with the title is Nuclear Reactor Design and Analysis using Program-Based Monte Carlo and Particle, or MCNP. Introduction, electrical energy is the main source of energy that is widely used and needed by human in everyday life. But the reserve of fossil energy source, especially petroleum, which are dominantly used as fuel for power plants, are running low. And the use of fossil energy harms the environment. Therefore, the choice to start building and operating a nuclear reactor as a power plant is inevitable. A nuclear power plant is a thermal power plant that uses one or more nuclear reactor as a heat source. It does this the same way as coal, oil, and natural gas power plants do. Namely, it heats water into steam to turn a generator. The difference is the way that it heats the water. Instead of burning fossil fuel, a reactor will heat water by bringing pellets of uranium close together until they form a critical mass. When uranium decays, neutrons and heat are released. If enough uranium is nearby, then the neutron will run into other uranium atoms, causing them to split apart or fission and release more neutron and more heat. Nuclear reactors submerge the fissioning uranium in water. The fuel heats up the water and the water boils and turns to high pressure steam, which turns the turbine. There are several types of nuclear reactor, one of which is a small modular reactor. Small modular reactors are nuclear fission reactors that are smaller than conventional nuclear reactors. Small modular reactors are advanced nuclear reactors that have a power capacity of up to 300 megawatt electric per unit, which is about 1/3 of the generating capacity of traditional nuclear power reactors. Among all worldwide small modular reactor design, the NuScale is a key to bring a new opportunity as one of the small modular reactor for the future of the nuclear industry. NuScale power module is a new kind of nuclear power plant that is smarter, cleaner, safer, and cost competitive. This picture shows the design and technology of NuScale. NuScale power module includes the reactor vessel, steam generator, pressurizer, and containment in an integral package simple design that eliminates reactor coolant pumps, large pore piping, and other system and components found in large conventional reactors. In this research, I using the MCNP program. MCNP program uses the statistical Monte Carlo method. This program simulates the life journey of a neutron, starting from the birth of the neutron until the neutron is absorbed by the material that makes up the reactor core. And there's the description of NuScale. NuScale is a typical small modular reactor, pressurizer water reactor type, having the power of 160 megawatt that equals to 50 megawatt electric. As seen in figure 1, the reactor contains a reactor core, pressurizer, and two steam generator, which is integrated in reactor pressure vessel placed in a compact containment. In general, well, the Nuscal is illustrated in figure 1, and table 1 deploys reactor core design parameter and reflector of the Nuscal. Nuscal core configuration consists of 37 full assembly and 16 control rod assembly. The core is surrounded by stainless steel neutron reflector not only to avoid neutrons released from the core, but also to increase the neutron utilization in the core. For future detail of the reactor full design, table 2 shows a feature of the Nuscal full, which is very similar to that of pressurized water reactor. The fuel used for Nuscal design is new fuel STP 2TM. A Nuscal full assembly is arranged in a cube array of 17 × 17 with 21.4 cm wide and active core 200 cm height, and the shorter length of the active core represents a significant difference between this full design and the other full pressurized water reactor design. The full assembly is supported by 5 grade spacer, 24 directing tube, and upper and lower sides of a nozzle which jointly handles 264 full rods. Each full assembly owns a central instrumentation tube. From 37 full assembly of the Nuscal, 25 full assembly use full mixture of uranium dioxide and gadolinium oxide, and the rest 12 full assembly utilize uranium dioxide pure full. All full design parameter and the full assembly structure of the Nuscal are respectively shown in table 2 and figure 2. Generally, the calculation methodology for the Doppler temperature and moderator constant as well as neutronic kinetic parameter of the Nuscal is deployed in figure 3. To begin with, the collection parameter information of the Nuscal reactor core, as seen in table 1, should have been correctly available. After all reactor data information completely provided, modeling of reactor core and full pitch should be developed, and this should be agreed with the requirements of transport code CNV. For FCNV, full assembly of Nuscal should be firstly characterized into full pin cell, void, and instrumentation tubes in cubic lattice cell. After that, the input code is made for MCNV and run, and then the values obtained to find alpha mode beta effective from neutron lifetime and neutron generation time. So that's all for my presentation. Thank you for the attention.
Okay, thank you for your presentation. And with that, I would like to invite the fourth speaker of today's session. Do we have Fahrisa in the classroom? Fahrisa Nurfadelia.
Present, sir.
Okay.
But sorry, my slide until now can't open, sir. Maybe my PowerPoint have a problem. So
okay. So we should proceed to the next speaker.
Yes, sir.
Until I will call your name again. Do we have Dara Rianti?
Yes, sir.
Okay. So the fourth presenter is Dara. Okay, let's slide from here.
Can you see my screen, sir?
Yes, we could see.
Okay. Assalamualaikum warahmatullahi wabarakatuh.
Salam.
Good morning, everyone. My name is Darnianti. Today, I will present about my research entitled Investigation of Landslide Prone Area Using Venus Lambercy Configuration Geoelectric Method in Dalamwangi, Bandung. The background of my research is landslide is a movement of soil mass, or can be defined as the displacement of slope-forming material, which can be in the form of native rock, weathered soil, embankment material, or a combination of these materials that move down and out of the slope. Indonesian disaster information data in the official web of the National Disaster Management Agency recorded the incidence of landslide in 2021 is 1,321 cases. Several impacts caused by landslide are casualties, deaths, injuries, and loss, material loss, damage to the environment and public facilities, also disrupting people's lives. Landslides can be caused by several reasons, including human and nature. One of the natural factors that influence landslide are soil layer, slip surface, and saturated soil. The slip surface is a water-resistant and slippery area which is generally consists of clay layer. The resistivity geoelectric method can produce the image of the subsurface rock layer based on the resistivity value of the rock type that constitutes the layer, which is estimated to be the cause of landslide. The purpose of my research is first, analysis of the underground structure in Dalamwangi area using the geoelectric method, and second, determine the structure and layer of subsurface soils in Dalamwangi. So what a geoelectrical method? Geoelectrical method is one of the geophysical survey method to identify the surface of the ground using the properties of rock electricity. A resistive geoelectrical survey is generally used for shallow exploration, approximately 500 meters below the surface. The working principle of geoelectric to inject electrical current into the earth. The electrode consists of two current electrodes C1 and C2 that deliver the electric current, and two potential electrodes reading the potential difference value after the current through the rocks P1 and P2. The four electrodes are plugged into the ground at a certain distance. The longer the distance of the current electrode will cause the flow of electric current can penetrate deeper rock layers. With the flow of electric current, it will cause electrical voltage in the ground. In figure 3, we can see simple electrode array in conventional geoelectric survey with C1 current electrode 1, C2 current electrode 2, P1 potential electrode 1, and P2 potential electrode 2. Measurement for resistivity surveys are made by the streaming current into the ground through electrode type, potential electrode and current electrode, and measuring the resulting voltage difference across the potential electrode. In its most basic form, the resistivity meter has a current source and voltage measurement circuit connected by cable to a minimum of 4 electrodes. In equation 1, expressing potential difference between the P1 and P2 potential electrode caused by the current injection on the C1 and C2 electrode. Current and voltage measurement are then converted into a type resistance of clear value in equation 2. Electrode configuration is the rules for placing current and potential electrode so as to obtain a certain pattern according to the objectives to be achieved. Each electrode configuration has a different geometry factor. The electrode configuration that are often used are Wenders-Lambercy, pole-dipole, dipole-dipole, and pole-pole configuration. In figure 4, is a electrode configuration. So in this research, I use Wenders-Lambercy configuration. Wenders-Lambercy configuration is a configuration with a constant system of spacing rule with a node of factor n, and as this configuration is the comparison of the distance between C1 P1 or C2 P2 electrodes with space between P1 P2. The geometry factor in this configuration in equation 3. This configuration also detects greater concentration of high resistivity below the P1 P2 electrode. That implies Wenders-Lambercy configuration sensitive to change in resistivity horizontally and vertically. The work procedures used in this study is divided into 4 stages, which are survey design stage, data acquisition, 2D data process, and data interpretation. The first stage determines the location of the measurement point and then makes the track according to the desired target. This study consists of 4 trajectories with 24 electrodes. In the field data retrieval is done by using multi-channel geoelectric as file Wenders-Lambercy configuration with 92 meters of track length and spacing of each electrode is 4 meters. Geoelectric data acquisition using geodesic software contained in PC. Rest2diff is used for 2D data processing so that the model is obtained resistivity inversion. Interpretation of data in this 2D based on the rock resistivity characteristic in 2D models. That's all for my today's presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, so after Dara, I'm going to invite Firas and Umilah as our 5th presenter. Okay, do we have Firas in the classroom? Okay, if we don't have Firas in the classroom, I would like to invite Muhammad Rafli as our 5th presenter.
Yes, I'm here. Hello.
Yes.
Can hear my voice, sir?
Yes, we can hear you.
Okay, sorry. I'm start to share screen. Okay. Good morning, everyone. I'm Muhammad Rafli. Today I'm going to presentation about magnetic levitation train powered by superconductor material. I am from Faculty of Mathematics and Natural Science Institute Technology, Bandung. Okay, first one, what is superconductor? Superconductor is one type of conductor that can produce electricity near zero resistance. So with this material, the resistance of electricity can near zero or absolute zero maybe. Okay, but the superconductor material can only happen in near zero temperature. It was 0 Kelvin. Yeah. This material have magnetic flux that expelled from material. So this material cannot this material cannot this material was expelled from magnetic flux, and this material have Meissner effect that can levitating over the magnet. And mercury is one of example of the superconductor material at 4.2 Kelvin temperature. Okay, and this is the graphic of superconductor where normal metal have resistivity even they have temperature 0 Kelvin. But the superconductor, when they reach almost 0 Kelvin, they have 0 resistance, electricity resistance. And this is the picture, the right picture is the magnetic field that expelled from the material. Okay. And this is the picture when a magnet levitating over the superconductor material. So the superconductor material is the bottom one, and the upper one was the magnet. Okay, nah, the application of superconductor is many, but the for important, I think the first one is lossless electrical power, but for today is not available, but maybe in the future can be applied. The second one is magnetic or bullet train that was applied today in Shanghai and in Japan, I think in Shinkansen, anti-earthquake building, and magnetic resonance imaging. It was applied today in medical. Yeah, and many other application of superconductor. Okay, and the magnetic levitation train have many advantage. The speed is up to 400 km/h. Of course, less power need, noise free. With this levitation, there's no distraction, there's no noise. The sound is very clear because the rail of the train is not don't have any contact with the train. But the disadvantage is the train need more coolant or liquid in the rail because the superconductor only works in very low temperature. So this train need very much expense in more than coolant or liquid. And of course it was, I think, not really efficient in tropical country. As we know, the tropical country have high temperature. Okay. And how it works? The magnetic levitation train works as we can see in the picture, in the left picture. The rail was the train was levitating over the trail because the magnetic field under the train was north and in the rail was north too. And with that same magnetic poles, the train was have force, and then the train was levitating. And what the power to make this train can move forward? It was the north and south pole in the side of the train. So the train, the magnetic field of side beside the train was attracted with the magnetic field of the train that can pull the train forward. So the south pole was attracted with the north pole. It produced the force that can make the train moving forward. Yes, it is what how it works. And this Shanghai maglev is one of the example of, I think, the fastest maglev train by today. It have a top speed over 400 km/h. The exactly was 431 km/h, and only 8 minutes from Pudong Airport to Longyang Station in Shanghai. It have a distance over 30 km. Okay, the Shanghai maglev was construction in 2001 and finished in 2003. Okay. And another example of maglev train is Shinkansen in Japan. But I choose Shanghai maglev because this is, I think, the fastest one and the best one, I think, for today. Okay, and then that is my presentation for today. Thank you. Sorry, sir, but I can hear your voice.
Okay, I'm sorry. Thank you, Rafli, for your presentation. Today, the next presenter, I would like to invite Ella Fatasha. Do we have Ella Fatasha in the classroom? Okay, if we don't have Ella, then we should move on to Jihad Fahri. We have Jihad Fahri in the classroom. Okay. No Jihad Fahri? Okay, very well. Let us move on to Radinal Satrio.
Yes, I'm here, Mr.
Yes.
Okay, could you hear my voice?
Yes.
Okay, excuse me, so I'm gonna share screen first. So this is my slide. Could you see it, Mr.?
Yes,
sorry.
we can see.
Okay, thank you. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Have a great day ahead, especially for Mr. Harry and everyone in this class. So, introducing, my name is Radinal Satrio and my ID number is 100-16668, and at this or in these occasions, I'm gonna deliver or presenting my topic, which is synthesizers, the physics of music, and how it changed music production. So this occasion or at the in this point in this meeting, there's 8-minute presentations, and I would like to maximize it, hopefully. Okay, so first of all, I want to talk or like reviewing what I've talked about before. So previously I've talked about introductions and then the purpose or aims, and then the last part is how does it work, or the synthesizer itself, how does it work, or how does it sounds, yeah, some things like that. And moving on, there's an outline for today. So for today material, I'm gonna deliver the introductions, but in more in-depth. So it's like more depth, like the digging more from the introduction. And then there's a basic theory about synthesizer. And then lastly, there's a model or how it model, like how does it form for the synthesizer. Okay. Okay, so I'm starting from introduction. So first of all, we all know that music is a big part of our world. Maybe specifically talking for me, music is like a big influence because we all listen to music everywhere, in the radio, on the TV, on the YouTube. There's a music video, and there's like a lot of genres that actually has not has a lot have a lot to do with how it influences us. So for me, music is like a big part that could help my brain to focus. And then we all know that many instruments have been invented and created necessary change in music industry. So we've seen some things from the instruments that traditionals like guitar, drum, and then there's a keyboard on into some things that are really, really new and fresh, like synthesizer. So the instruments basically change from how it just deliver the basic notes into creating a new sounds, creating a new notes that we could experiment to. We could hear a lot of sounds that otherworldly or like trippy. It's like a product from how instruments change toward in the music industry. So yeah, and then specifically talking about the change in music industry, we all know that electronic music become one of mainstream genres. So we like listen to many genres of the song, pop, rock, jazz, but a lot of that is like could be specifically could be said that is just traditional. There's an electronic music that actually really just has a lot of range. It's basically because it's creating a new sounds. It actually could creating a new music that never been done before. So the electronic music has a lot to do with physics. Physics is a big part of music, especially electronic music. Many aspects of music require an understanding of physics. So the musical instruments are constrained by the laws of physics, and the development of instruments could not have progressed without the knowledge gained through the study of physics. So if I could say, like, for example, the modern grand piano is a marvel both of aesthetic beauty and engineering. So it has a lot to do with physics and engineering itself. It simply could not have been built before the 18th century because it required the current knowledge of mechanics and state-of-the-art technology. So maybe another example is how sound wave created. So sound wave is really rangeful. It's like really has a lot of range, and physics is actually help through development of the sound wave itself. And then the last part is synthesizer. Often abbreviated as synthesizer or synth, is an electronic instrument capable of producing a wide range of sounds. So it literally just create a new sounds. So you could actually invent something new, invent what you've been thinking, and not sticking in onto the traditional music. Okay. Okay, so the basic theory. First of all, there's a synthesizer, also spelled as a synthesizer, is an electronic musical instrument that generates audio signals. So I take it from a sound synthesizer. It's like from G.D. Shaw from February 73. So as well, with that being said, synthesizer could create a new sound. That basically it's like it could help us through our imagination. So there's a somehow it's like components of a synthesizer. So in a basic way, it's literally keyboard, or there's in the left there's a keyboard or the input. So if we want to create sound, the keyboard actually goes through a PCO, and then there's PCF, and there's PCA. So all of that is actually creating or like suspending a music or a sound. So the PCO is like oscillator. Oscillator is one of the main components of a synthesizer, and then there's the FCF. FCF, a filter. A filter is actually help us to I'm sorry. So these sounds may be altered by components such as filters. So these filters is cut or boosting frequencies. And then there's FCA. The FCA is actually amplifier to making the sound bigger. And then there's an output at the right side. Okay, so I took it from Saint diagram from Wikimedia. Okay, so there's a model. Synthesizer is usually model like this, like in the left
Sorry
side.
to interrupt, but you have 1 minute to close your presentation.
Okay, thank you, Mr. Okay, I'm gonna faster my presentation. So this is actually how it sounds, and it sounds like this. If you put this one. So that's basically the sounds of a synthesizer. It's just like creating a new sounds like tweaking, and that model is from Juno and TB, one of the several common synthesizer. And synthesizer is having a lot of form that it actually help through a robot character in Star Wars franchise, create by George Lucas, and then there's keyboardist Kate Emerson with synthesizer. So it helped to change our industry, music and then film. So it really has a lot of functions. So with that being said, I'm really I want to say thank you so much for your attention. And if there's discussion that want to going on, you can contact me at Muhammad20358 at mail@unpad.ac.id. So thank you so much, Mr. and everyone.
Okay, thank you, Adina. The next presenter is going to be Fahrisa. Okay, Fahrisa.
Yes, sir.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. Good morning,
Salam.
everyone. My name is Farisa Nurfadliyah Bahraini. I'm from Department of Physics, Bandung Institute of Technology. And today I will present my research, talk about multi-technique for the characteristic of the sidewall core of hydrocarbon reservoir rocks. For today's agenda, I will only discuss about the interaction, theory, and the characterization method. For the first is introduction. In human life, oil and gas are a non-renewable natural resource. This natural resource provides many benefits that human needs in their daily activities. There have been technological development and optimizations of oil resource extraction in recent years. One of the methods is enhanced oil recovery or EOR method. Optimization of this method can be done by characterizing the rock in the hydrocarbon reservoir area. As you can see in the image on the slide, if we take a block of sandstone from the field scale, the block of sandstone as a reservoir scale, we can characterize it to see it in a microscope scale, to see the physics and the chemical properties of the rocks that met the field. In this research, several different techniques will be used to characterize the sidewall core sample of hydrocarbon reservoir rocks. The techniques we are used are microcomputed tomography or microcity. The next is X-ray diffraction or XRD, and the last is scanning electron microscopy. About the theory, what are minerals and rocks? Minerals are substances that occur naturally and have physical and chemical properties related to their structure and compositions. If we have many minerals composed, we can have a rock. So a rock is a collection of minerals arranged in a single unit to form a larger size. There are three types of rocks. The first is igneous rocks. Igneous rocks is the result of the cooling molten magma. For example, there are granite, scoria, and others. The second is metamorphic rocks. These rocks are the result of mechanical, thermal, and chemical change from igneous rocks. And the third is sedimentary rocks. These rocks are derived from weathering of rocks due to tectonic activity or because the chemical, physical, and biologies. Next, about the rock characteristic. The first is porosity. Porosity is the empty space that is created throughout the layers between the grains that make up the rock. In mathematically, the porosity is expressed as the equation follows in the slide. It's about the pore volume and the bulk volume of the rock. When we looking at the picture on the slide, there is an effective porosity. It is the interconnected porosity. And then there is an non-effective porosity, or we can call it our isolated or closed porosity. The second characteristic is clay minerals. Clay mineral is a type of soft natural rocks in the form of fine grains with the diameter of less than 0.005 millimeters. And the clay minerals are a characteristic of minerals on Earth that have varying amounts of ions. The physical and chemical properties of rocks can be caused by the presence of the clay minerals in them. What research technique are used? The first is microcomputed tomography or microcity. This method is one of the digital rock physics techniques. This method is a computer-based digital image simulation, so the characteristics such as porosity and rock permeability can be estimated. This is an illustration of how microscopy works. There is an X-ray tube that emits the X-ray beam to the sample on sample specimen. A sample specimen can rotate 360 degrees, and the detector will record the signal that is sent to the computer and processed into a digital image. Computers are also used to control the X-ray tube and the motor of the sample specimen. Second is X-ray diffraction. X-ray XRD used to analyze the structure of the crystalline, semi-crystalline, and non-crystalline material of a sample. XRD will use with powder sample powder, and utilize the principle of diffraction and the high energy of X-rays. This method relates to the characteristic of the electron pairs in an atom. If we see this illustration, there is an X-ray tube that shoots the X-ray to the sample, and then the sample becomes unstable and must release energy to achieve stability again. So the detector will record the energy as a signal and obtain the sample mineral phase. And the last is scanning electron microscopy, or SEM. SEM is the result of the development of the light microscope. SEM used an electron beam to obtain a digital image of the surface morphology of the sample. There are 3 detectors in this method, namely backscatter electron detectors, secondary electron detectors, and the last is X-ray detectors. X-ray detector will provide information about the elements contained in the sample. Next is the flow diagram flow or flow chart about the research process. First is the sample must be prepared. Do the process using 3 methods, microscopy, XRD, and SEM, and then collect all data from each method, analysis of this data, draw the conclusion, and research is complete. I think that is my presentation. Thank you for your attention, and thank you.
Okay, thank you, Fahrisa. Okay, I would like to recall the following names. Do we have Jihad Fahri? Do we have Jihad Fahri in the classroom? Okay, do we have Ella Fatasha? Do we have Firas and Umila?
Yes, sir.
Oh, okay, we have Firas. Okay, Firas will be the 8th speaker of today's session. And if Ella and Jihad is not attending the class today, then Firas is going to be our last presenter of the 8-minute student presentation.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
My name is Firas Anumillah. Here I'm going to present you about optimization design of high-speed transport inspired by nature. outline is background, and then basic theory and method. Okay, first one, Indonesia is an archipelagic country with a sea area of up to 17.7% of its total area and 17,504 islands. This island consists of a major island, namely Java, Kalimantan, Sumatra, and Papua. However, many areas in Indonesia are challenging to access because waters and various other difficulties. To overcome this problem, the government needs transportation facility that can reach remote area, especially those difficulties to access by land. Then we know that shipping industry has been thriving industry since the start of the Industrial Revolution, and now is it categorized as one of the large-scale economies. And then cleaner ship is facing an unexpected development on the size of the vessel, as it has increased endlessly year of year. The escalation in vessel size decreased both fuel and capital cost per cubic capacity. And then reducing the resistance may help in improving cruising speed and reduce fuel consumption as well. The purpose of the research is propose a much more economical and practical modification to obtain a better ship cruising characteristic with a relative cheaper solution, and then gain fuel saving eventually in return. But the theory is shark skin denticle. Shark skin denticle is shark skin structure are rough and hard, and they are made up of the dermal tooth-like denticle, which is called as minuscule placoid scale or denticle. These denticles have pulp and cavity cover with enamel or pictodentin. Then shark skin is designed with microstructure feature that effectively control naturally occurring turbulent vortices, which leads to less momentum transfer and shear stress, and thus reduce drag. The study include the investigation of on the drag reduction, which are inspected by nature, such as drag reduction to the unique structure of the shark skin denticles. Mimicking biological shark skin denticles is an example to see how nature can inspire us to come with idea about many by studying and understanding mechanism of natural phenomena, human can reproduce this phenomena on demand. Okay, drag force. The pressure drag and friction drag are the two most basic type of fluid drag. And then drag of marine vessel has three main forms, including drag pressure drag, and then skin friction or viscous drag, and last one is wave making resistance. This is the drag force. For the method of this research is computational fluid dynamics. CFD is branch of fluid mechanics that use computer-based numerical analysis and algorithm to simulate, analyze, and solve problem in fluid flow. And then CFD makes it possible to use actuation governing fluid motion for a large range of complex situations, providing both insight on and quantitative prediction. Thank you. That's all for me. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Hiras. So I would like to recall the proposed presenter of today's session. Do we have Jihad Fahri? Okay, do we have Ella Fatasha? Okay, do we have students who haven't been presenting yet in the classroom? Okay, so with that, I would like to thank all the students that has been talk about their selected topics in this session. In the following 2 weeks, you're going to present the whole set of your topic, and we're going to have a question and answer session in the final 15 minutes presentation. And next week, we're going to move on to the next subject related to the how we create poster presentation. And I'm going to talk about how you are preparing for your poster presentation, because in poster presentation, the topic is not going to be the same with your oral presentation. It will be a group assignment that you're going to read, and also to create a poster based on the readings that you are assigned to. So I will put more details on next week's activities on poster presentation creation, and also what are the assignment and what the assignment are for poster presentation. And if time is permitting, I will also give you some kind of a feedbacks that we gather from the 8-minute student presentation that we have for the last 2 weeks, from Monday, Thursday, last week until this week. And after that, we're going to start the final presentation in the second week of April. And then your poster presentation submission should be done after the Eid al-Fitr holiday. Okay, thank you all for attending the class. I will stop sharing the screen, and I will stop the recording of today's session.